Hello and welcome to the VBA tutorial part 2. Today I'm going to be speaking about the history and logic of VBA, the VBA interface, how to get to it, programming standards, and maybe I'll get into some of the standard definitions I'll be working with. The history of VBA is written here. There's about 100,000 write-ups of it all over the internet. I'm not going to bore you with it. Suffice to say, your computer has hardware in it. It has software that tells the hardware what to do, and that's how you actually talk to your computer. The language is an interpretation of what you're telling your computer to do. You'll take a bunch of words, they're in English, you'll sit down, you'll type them out on your keyboard, and eventually your hands will start to hurt. This is caused because you're not used to using these keys. They're all the keys above the numbers. You'll find all the different types of brackets. Tab gets used overly much, so get used to using tab, get used to using your keyboard. Take breaks as much as you can when you're coding, but in the end, have fun with it. What you'll find that the first thing you'll do when you start writing code, if you're anything like me when I was learning it, you will start to write a lot of code. Tons and tons and tons. You'll write hundreds of pages of code. Well, maybe not that much, but you will write a lot of code. And as you get better with it and more understanding with it, learn new functions, different things like that, the code will start to minimize, especially if you learn multi-dimensional arrays or, well, basically multi-dimensional arrays will shorten your code by a lot. Even using arrays, filtering arrays, things like that. I'll get into them later, but anyway, do your best with your hands. I find that if you keep them warm, you put them under hot water, put them under your pillow, something like that, they will feel a lot better. The bottom part here, I've talked about a close relationship between program logic and actual real-life logic that we use every day, and just telling our computers to follow that logic. Programming logic, if you were to think of it, try teaching your kid, if you have children. If you don't, try teaching anybody anything that has zero knowledge on it. You have to start off teaching them the steps of how things work. Even the minimal things like standing up, walking 2 feet forward, putting your foot out ahead of you as you walk, flexing the muscles in your feet, putting your hand up in the air, closing your hand, closing each of the joints in your fingers. All of these things are steps that go into logic. Those are the pieces you'll program in. You'll program your function and your modules and everything you do exactly the way that you want it to work. It's not like recorded code though. When you start recording code, you bring in a lot of crap that you really don't need. So don't record code. Don't use the record button unless you really have to for silly things like formatting or colors. Just type it out. The bottom piece I talk about is recorded code versus coded VBA. You can basically make your computer do anything. As I mentioned here, I'm not going to the basics of what you can do. I'm going to bring that to the forums. I'm going to do a lot of in-depth work there on a lot of things because the scope now is here, personally, that I'm doing this. You won't have to worry about the limitations that I am stuck with at work. I would just caution you against using them because if you're going to use that logic and making your computer do anything at work, you might get in some trouble with it. So do the small things, easy things, the ones that you want to do yourself. The next slide is about the VBA interface. As I mentioned at the top here, VBA is used universally through most of Microsoft's major applications: Outlook, Word, Excel, Access, PowerPoint, Project. The rest of them have it as well. They allow really good interface between each of these programs. So you can make a Word macro, make it program Excel. You can make an Excel macro and you can make it program Outlook. That's one that I use a lot, is the Excel programming Outlook to do things, because you can generate tables, you can generate formulas, well, sorry, not formulas, but anything you can generate in Excel through your macro. You can pump it out to an email, interface it Outlook, and have Outlook send it out. which is really convenient in a lot of ways. It's also good for reporting, good for automated things. It's good for everything. It's just fantastic. And I may go into Outlook and different types of VBA interfaces, but for the moment I'm going to focus on Excel. To engage the VBA interface within any of the Microsoft applications, which is controlled by VBA, hold down Alt, press F11. You'll see the screen in the middle pop up. This is the VBA interface, which is the backbone behind the active document you have up. And for the latest version of Excel, you'll need to enable macros if the program prompts you to do it in order to use or code a macro. This is a stability function at work. It may not be on your home PC, so you may not see that enable macros. There is an option within Excel to permanently enable them, but I believe that our corporate security turns it off. So every time you reopen Excel, you'll have to re-enable these macros. It's kind of a setback, but it's not too bad. There is code that you can put in that will override this. It's on the loading function within Excel, so if you can pick up your macro, have a macro running from another program like Outlook, make Outlook initiate Excel within your macro, you can enable it before it goes through. But either way, it's a little high tech, or whatever you want to call it, a little in depth, so don't go there. Just press the enable macros button when it pops up. You'll also see here, it's kind of small in this picture, actually very, very small, but insert. You press insert and you click module, and it will it puts this piece in the middle here, so you can actually start typing. Right there it says module 1. I'm going to go into that later, but that's just how you can start typing code. The programming standards I've written at the bottom here. The basis of this is writing clean code. Clean code is very essential to programming etiquette. You write it this way so you can reread it yourself. The upside to it is that you can follow the code for debugging and ease of use for restructuring. The downside is pressing tab repeatedly. As I mentioned earlier, it's a very unused key for most individuals. If you're going to use passwords on the code, remember, very easy to use passwords. Write them down and distribute them, as they're very easy to forget. I personally don't ever use passwords, but I guess I can understand the reasoning behind why people do, especially if other people using your macros. Generally, I build them for myself. That's why I don't use passwords. This clean writing concept is essentially, if you look at code, I had 2 images here, but I had to strip them out of my program. If you have a big jumbled piece of garbage code and it's non-stop code all along the entire thing, it's very hard to read. So every time you start a new piece of code, indent it, and as you're ending those pieces of codes, bring them back to the start, and the code will flow. You'll see a lot of definitions and tutorials, things written like this. Every time you look at my code, it's just way easier to read. Another etiquette technique on the bottom that I mentioned here is the heavy use of comments within your code. I'm going to show commenting on the forums so you can learn how to do it. Essentially, it's just a single quote. It's beside the enter key. You don't need shift to use it. Every time you hit this, your code in Excel VBA, for using a standard Outlook color scheme, it'll turn green. You can type anything you want beside it. You can type, James wrote this code, and it won't interfere with the way the code actually works. Comment is just whatever you want to type. You can hit the single quote and type in I ended my code here, and that's the end of it. It allows you to write instructions in each line within each section of your code to instruct yourself what you're doing. It's also good if you're going to hand your code to other people to look at, as it can be sort of a continuity point. Sorry, bad word, but place your comments in if you're going to use them. Don't over heavily comment anything. I wouldn't recommend it because it makes the code very hard to read for you. If you're going to pass code to other people, maybe comment it, and then they can decide if they want to remove your comments after. Standard definitions, basically throughout these programs that I'm going to be doing here, throughout the forums and anything I've written, I use a lot of standardized definitions. The definitions are terminology to ensure we're all on the same page. It's hard to explain something if you don't understand what I'm talking about. For example, some individuals refer to the physical computer as the CPU, this box that you see here that everything's plugged into. Some call it a hard drive. The hard drive actually is a piece inside the computer. The tower, generally the tower is referred to as the shell on the outside here, this piece of plastic that you see. It doesn't do anything when it's alone. You can buy it for 30-40 bucks. It doesn't really make a difference. The computer is often referred to as the entire computer, including your monitor, mouse, keyboard, and tower all together. And the box. I don't know why some people call it this. I guess it looks like a box. And some don't even have a name for it. I call it many things, usually the PC when I'm referring to it. I don't like Macs. I guess that's my bias towards that. Anyway, we'll look on standard definitions, and this is the reason. If I came to you and said unplug your tower, you might be a bit confused. If you came to me and said unplug your hard drive, theoretically, I guess I might go into the computer, unscrew it, pull the side casing off, take my hard drive, unplug it, and hand it to you. I mean, obviously it's pretty stupid, but it's just the idea. So the reason I created this section is to touch on a few more of the common used definitions just to get us on the same base. I'm going to go through a few of these, and once I get through them, the next module will start off on actually showing you some programming techniques. I'll go through these pretty quick. You can also read up on them, have a talk with me about them if you want, and I'll try to explain them a bit better. The syntax is generally what we call system code. For instance, if you type proper syntax within your program, it'll work. If you use bad syntax, the program will not work. Syntax is the way you type. You have to use these words. You can't use your own words when you're typing code. You can't use the word help in the code. It's not a function. It's not a piece of code, it's nothing. You have to use what's typed into the program. So as we go through it and you see code like this, the word select is proper syntax. Determine is not. An array is. I'm going to show you a lot of these things later, and I'll help you make more sense of it. Syntax is the words in the language that you use. The workbook is the actual Excel document you'll be using, the XLS, XLSX, XLSM. It consists of a lot of things, including spreadsheets, modules, forms, and data. If you think of your Excel document that you have on your computer, that's your workbook. That's what we're going to refer to it as. A sheet is a tab. If you look at the bottom of your Excel, I don't have a good portrayal of it here, but if you look at the bottom of your Excel document, standard when you open it has sheet 1, sheet 2, sheet 3. Those are your sheets. That's what we're going to call them. A module is where you start writing your code. You can think of it as the area that you type, I suppose. It's an interface you type into. You can create and maintain many modules. You can bring them between different programs, and you can think of it as a library of functions that you build. It's hard to explain the way that it works, but if you wanted to type out a lot of different code, you could, and then you can take it out of that Excel area and you can put it in a standard area and reuse that code multiple times. It makes it handy. I've never built my own system library. Maybe through these functions I will, just to get stuff out there so people can see how things work. Maybe it'll be a project that I come up to later. The function is a pre-programmed set of instructions which your creator used to allow for quick reuse of code over and over the same process. This is what I consider to be the fundamental basis of programming. If you want to think of it in regular everyday logic, you can think of it as a series of steps used to do something. If you wake up in the morning, you prepare your day, you're going through a series of steps. In this case, the function would be called go to work. Now I use a lowercase g at the start, and I define functions with every next word in them with a capital. As you see here, go to work, and the steps would be the various events which take place in your morning routine. So if you woke up in the morning, you took your function, you put something into it, you're doing something. You're repeating it every single day, that function. That's why we write code to do it, because a function is handy, basically. If you don't use a function, you're going to get to a point where you're going to retype the same set of code over and over, and then your code just becomes huge. A lot of the time you can use 2 or 3 functions and keep referring to them, keep coming back to them and saying, I'm going to dump this item into my function, I'm going to dump this item into my function, and I'm going to get this out of it. Maybe an easy way to think of it is a date conversion. If you have date in a certain way, it says March 1, 2016, you change the way that looks to 03/01/16. That's going through a function to change the word March into 03. It's as simple as that. I'll go really far into this and show you a lot of stuff about functions later. A loop is a specific function which is run many times to carry out the same process. You can specify what you're wanting to happen, such as changing the cell format in this exact example I have here, and how many times you want it to happen, from 1 to 50, or however many times you want. You specify the start, you specify the end, and how many times it's going to work. It's a very critical piece of programming. The majority of most of the work you complete in Excel will be use of loops, and I'll explain how to use it and how to code these in a little while, probably in the next module. Suffice it to say, a loop will take you through repeated code a whole bunch of times. If you think of this little guy here knocking these dominoes down, by the time he gets back to the start, it's standing up again and knocks them all down again, knocks them all down again, etc. Reason for this is because a lot of the time in Excel you want something to happen many times, not just a single time. It's as easy as that. A pretzel obviously is not a real programming definition, but I use it over the years. It's when you get too much logic in the same area, too many dimensionals in your array, and it gets very confusing. You'll find for some reason, and I don't know why, even I do it, I still sit there and I find if statement, if, and they're all structured inside each other, and they might be 10 deep. It just gets crazy. Multi-dimensional arrays, if you want to think of that, think of a 10-dimensional array. You got a calendar, you have your minutes, your hours, your days, your weeks, your months, your years, and then you have a calendar on top of that that's strung through multiple computers, and then on top of that you have multiple systems or networks, and then you have multiple financial institutions. These all compound on top of each other, and it gets very, very confusing on how to organize your data. I call it a pretzel. I like pretzels. Easy as that. An array, basically an array is one of the larger, more difficult pieces of programming, and you're going to look at it and say, well, what the heck's an array? How do I use this thing? It's very difficult to learn. That's what I've been told anyway. Variable which contains multiple areas for data. Essentially, you could think of it as a spreadsheet in Excel, but it's held within system memory, so you don't actually see the data. There's something called RAM inside your computer. It's called random access memory. It sits there, and when you run an array and you put data into it, it sits inside your computer's memory. It's really handy to use. You can dimensionalize it with many spots to place data in the elements, and it will hold that amount of data. For instance, if you made an array called account numbers, you could give it 10 spots or 10 areas to put data. In the first spot, you could put one account number, in the second, another account number, third, fourth, all the way to 10. Another easier definition that a friend of mine thought of to tell into this is a list. Which, if you could think of a shopping list where you'd write down the various things you want to buy, the paper would be the array, and what you're wanting to buy would be the elements. So if you can visualize in your head an Excel document with rows and columns beside each other, that's a very good definition of a two-dimensional array, because you have columns, you have rows, and they open up. If you have a 10 by 10, you have 100 elements in there. The problem is there's more than 2 dimensions when it gets to an array. It's very difficult to understand. I'm going to go really in depth on the forums into this because it's very important to use. I have 3 more, and then I'm going to end this off because this is getting long. and I apologize for that. If you want to stop, you can just continue reading on your own or work on these or skip them if you want. They don't really matter that much, but I built this module, so I thought I'd work through them. Debugging is a very good and handy step that you can use when you're writing code, especially if you're finding problems happening in it. You can go into the code, and I'll show you on the forums how to debug your code. But what you can do is stop it at every point, and you can highlight variables, you can highlight items within your code and watch them as they move through your code. You can step into it, it's called, and every time you press the step button, it shows the next element in your code. It's really handy, and it'll help you out. Runtime errors are poorly written code, or if you're writing, I guess if you're in the process of learning, you'll find a lot of runtime errors if you're not lucky. It'll appear if you try to make your program do something illegal or logical to the system memory, like placing a value like text A, B, or C, etc. within an integer value, which can only contain numbers. So when you define these variables, you say account number, and you call it an integer. Integer is just a number. It's a small number. I put 1, 2, 3, 4, 5 in there. If you try to put the letter A in there, it doesn't flow. It's not an integer. It can't take it, so you get a runtime error. There's a lot of runtime errors. There's thousands of them built into Excel, and you'll find a whole bunch of really messed up ones eventually. In the last small bit here, I mentioned if you try to open ADP without actually opening it, you're trying to control it, and you're trying to say do this, ADP is not open, so you obviously can't do it. And then the last piece here in the bottom, break is a way to pause your code. Sometimes if you have a really big loop, you want to pause it to see what's happening and see if it's actually running or if your code's broken. Sorry, late at night. If you debug your code, you can click the left bar where you type each line, a purple circle will appear, and then you can run your code. As it reaches each line, the purple circle will stop the code and it'll break and it'll let you proceed. So it's a very handy way to stop and debug your code. When I get to the debug area, I'll show you a lot more on this. I apologize for the length of this module too. The next module we will get into is this, talking about programming logic, which I'll go through quickly, and then I'll work into defining these variables, which is the start of actual programming. I hope you're staying with me on this. Next one will be a lot better. Thank you very much.